now, with the right phone in the right city, you can get download speeds of over 1 gigabit per second, which is 20 to 30 times faster than typical 4G LTE. But the key part there is right phone and right city. 5G isn't remotely widespread, and the array of technologies that make it up are still kind of a mess. And array of technology is key because 5G isn't one thing. It's a collection of various improvements, including antenna design, cell towers, and a wider set of radio spectrum, and it's still unclear which changes there will make the most difference. With different carriers focusing on different tech, your experience of 5G may also vary widely. Well, the change isn't really a hardware one, but 5G uses a much broader range of the EM spectrum and dedicates more bandwidth to those channels, i.e. it gives people bigger slices. Traditional cell signals have mostly fallen between 500 and 2500 megahertz frequency on the EM spectrum, but 5G can use frequencies up to 20 times higher than that. The official 5G NR, or New Radio spec, breaks into two chunks. FR1, which covers around 400 to 6,000 megahertz, and FR2, which is about 24 to 50 gigahertz, the much hyped millimeter wave. Quick refresher, cell signals are an electromagnetic wave, just like light or radio waves, and hertz is the frequency, or the number of peaks and valleys that wave carries per second. Lower frequencies are easier to transmit longer distances. They can wrap around or pass through most objects. For just this reason, some companies like T-Mobile and AT&T in the US have been rolling out so-called low-band 5G networks at 600 and 850 megahertz. In some cases, not actually that much faster than 4G. Because of this, most providers around the world are actually focusing instead on the mid-band, which currently runs between more or less 2500 and 4700 megahertz, but may extend up to 7000 later. Channels can be between 50 or 100 megahertz of bandwidth, enabling much higher data speeds, maybe hundreds of megabits. Aside from Sprint, the US carriers are largely ignoring the mid-band for now, and instead focusing on that high-end, the millimeter wave between 24 and 50 gigahertz. There is a lot of available spectrum here, enabling channels as wide as 800 megahertz, but it comes with some big drawbacks. Cell signals use something called QAM, or quadrature amplitude modulation, which twists the sine wave of the signal into shapes that get decoded into collections of ones and zeros. 4QAM has 4 shapes that correspond to 00, 01, 10, and 11. 16QAM has 16 shapes decoding to 0000 and 0001, and you get the idea. To get the most out of those high bandwidth data channels, they've actually been paired with a new technology called massive MIMO, which stands for multiple input, multiple output. Traditional 4G towers generally had between 4 and 32 antennas, and in good conditions, your phone may actually be able to communicate with more than a single antenna at once, boosting the amount of data it can send or receive. Most high-end phones currently support 4x4 MIMO, meaning they can have 4 active connections to a tower. This is definitely a best-case scenario, though. Many phones are actually still 2x2, and even if your phone supports 4 connections, it's not a guarantee the cell tower can supply them all. A massive MIMO base station will have between 64 and 256 separate antennas, and a 5G phone should be able to achieve 8 or even 16 connections, which are called layers. A lot of things would also benefit from another advantage of 5G, lower latency. 5G claims to be able to drop the delay for a phone communicating to a cell tower to as low as 1 millisecond, down from 20 to 70 milliseconds for LTE. Now, this is probably years away in reality, but it could help with mobile gaming, especially as services like Stadia and xCloud and NVIDIA Live are now talking about streaming games directly to your phone. These data speeds are also probably a requirement for true automotive automation, with self-driving cars receiving data from sensors at stoplights and intersections and sharing their position and intentions with the cars around them. But those 1 gigabit speeds people are getting right now on 5G, that's how fast 4G was supposed to be when the standard was first set. But the average LTE speed in the US is still only between 16 and 30 megabits per second, a fraction of its potential. The networks we are seeing right now in 5G are essentially prototypes.